Can you hear me now? Can you hear me now? I try to talk. You should be able to listen my voice.
No, Luca.
No? I try to talk. Okay, sorry for this mistake. So I can share. Okay, now you are seeing my screen. So I will repeat what I said, but it was just uh, just one thing. So this is the basic, the starting page of MATLAB. So we will talk about the basic tabs that you need to use in MATLAB. So the first one is the current folder. You can see this tab on your left, and this is just a browser from which you can access your folders and open your files. Then there is the Workspace tab that you can find on your right. You can move your tabs whenever you want. Then we have the command window, that is the tab that you find at the bottom. And here you find the command window, that is a sort of terminal from which you can just type your commands. For example, if you type docplot, it's a command, you will see that the command is executed. Right now we are not working on a file, so we need, before starting we need to create a file. How can we create a file? Well, we go to New, and from here we can select Script or Livescript. The difference between the script or the Livescript is that with the Livescript you can see what you are, you can see your outputs right in your code. And if you're familiar with Python, we can see Livescripts like Python notebooks, in which you can see your plots, while the traditional MATLAB script is more similar to the traditional Python file that you have to run, and it opens the different plots in other windows. Today we are going to see Livescripts, so I create a Livescript, and that's it. In the Livescript, of course, we can type our command. For example, I can create a variable a equal 1, and then we can, of course, run our code. How can we run the code? Well, there is the run button. Okay, and here you see the output of your code. This is not the only way of showing your code. There is also the output inline mode. Here you see the output just below your code. Then there is the mode hide code, and in this mode you see just your outputs. Today we are going to use the output inline, so we will write the code and we will see the output just under our code. I think that this is more or less all about the graphic interface. Another thing that I have to say is that in Livescripts you can also write text. Why text? Because you you may need to write comments to improve the readability of the code. So if you want to write text, you can write text. This is not code. This is a sort of comment, and you can decide the size of your text, so you can create an interesting documentation. Okay, so the last thing that I want to show you here is that when you run the code, you can decide to run everything, but you can also decide to run a subsection of your code. How can we create these subsections? Well, with a section break. Now I create a section, and as you can see, this line separates two different sections, and here I can create another variable that is b. Let's say b equal 3, and if I run the first section, so now I open the workspace. Here in the workspace we see all our variables, and this is useful if we want to keep track of what we are doing. I run the first section. I have to... Okay, now it's fixed on the right. So if I run just the first section, we will see a equal 1. The second part has not been run, so if I want to run also the second section, I have to go to the second one and I run it. In this way you can you have a better control of your code. You can test just one section. Another interesting thing is that in the command window you can type part of codes that will not be written in your file, but these commands will be executed in the same way. So if I want to rename the variable a, and I say a equal 5, you will see that without having a specific line of code in our file, we have renamed the variable b. Okay, so these were the basic things. I think we can jump to the code, to some examples that I prepared to you. Okay, a recreation. Oh, I quit MATLAB. Okay, I think it's loading. Yes, okay. So I can minimize the workspace tab, since we are going to look at our outputs right in the code with the Livescript. So, first point, arrays and matrices. These are the basic variables in MATLAB. We can say that arrays are all these kind of variables. There are matrices that are a sort of chessboard in which you can put your values. Then there are row vectors that are linked matrices. They have just one dimension. And then, of course, there are column vectors and scalar. You can see scalar as a one-by-one matrix. So we can start by creating row vectors and column vectors. the syntax is very simple. For row vectors, we can use this syntax, so we will use square brackets, and we type our values separated by a space or separated by a comma. There is no differences between the comma or the space. It's up to you. Then for column vectors, we will use semicolons to separate our values. So we can see the examples. So if you want to create a row vector, we will type the elements separated by a space. Now I run the section, and here we have the output. We have our row vector x, that is 1 by 4, and it contains our values. Just to check, let's go to the workspace. We can see the x, and here we find our variable. So in the workspace you can always check the variables you have created. So second example, we want to create a column vector. So the syntax is again very simple, but this time we use semicolons. So I run the code, and here you see our column vectors 2, 11 and -8. I put it a space, but it works also without the space in this case. So okay, I run the code and you have the same output. This is how we can create column vectors and row vectors. But when you create a row vector or a column vector, you can also use functions to define the values of your vector. So, for example, we can use the cosine of pi, and pi elevated at 2. So if you run this section, you will see that the variable z is -1. That is the value of the cosine of pi, and the same is for the pi. So another interesting thing that you may want to know is that it is possible to transform column vectors to row vectors and vice versa with the transpose operator that is this one. So let's see, we have our row vector x, and we want to transform it into a column. So we will use our operator transpose, and here we have w, that is x transpose, and x transpose is the transpose of x. Okay, so now we go to matrices. Again, matrices, as we said, are sort of chessboard in which we can write numbers, and they work in the same way. So if we want to create this matrix, first we will define the line, and then we will use the semicolon to define the line after. So in this case we will type 1, 2, 3, then semicolon, 4, 5 and 6. Again, this is true also for this other matrix, but this time we have 3 lines, 3 rows, so we will use 2 semicolons. So again, 1, 2 semicolons, 3, 4 semicolons, 5, 6. Okay, we have seen how to create manually our matrices and our arrays, but there are functions that allow us to create these matrices in a sort of automatic way. And here we have the most used functions for initializing arrays. So we have the zeros function that creates a matrix full of zeros. Then we have the ones function that, as you can guess, creates a matrix full of ones. Then we have the I matrix that create an identity matrix, and if you don't know, an identity matrix is a matrix full of zeros but with ones on the diagonal of the matrix. Then we have the rand function that creates an array, a matrix with random numbers in the interval 0, 1. And then there is the function randy that is an extension of rand, and it creates a matrices with random numbers in an interval that is defined by you, so you can decide the interval. Let's see, for example, the ones matrix. Ones matrix, we can, of course, decide the size of our matrix. We first type the number of rows and then the number of columns. In this case, we want a matrix with 3 rows and 4 columns. We run our code, and here we have our matrix 3 by 4, as we have specified in the arguments. What if we use zeros but with just one argument? If we type zeros 4, the MATLAB will automatically understand that we are going to create a square matrix with size 4 by 4. So the second dimension cannot be specified. And here we see the 0, 0 matrix 4 by 4. If I type 4, 4, it's the same thing. But for simplicity, MATLAB works also with just one argument when you want to create a square matrix. Okay. So next point, as you can imagine, we can compose our arrays like Lego blocks. The important thing that you have to take into account is the dimension of our matrices. In this case, sizes matter. So we have to check the dimensions of the matrix before using the concatenation. We can compose matrices in this way using the semicolon, one on the top of the other. But we can also we can also combine matrices in a sort of puzzle, again respecting the sizes of the matrices. So here I created an exercise, very simple, in which we can try what we said. So we first define these matrices and these arrays, and then we compose a matrix P composed in this way. As you can imagine, it's simple to do it. So first we will consider the matrix A, and we will say that here we can put A. Then under A we have Z and X, so we will use the semicolon. Z and X are together, so we can write this Z and X, but keep in mind that we can also use the comma. It's the exact same thing. Okay, and then on the right we have our matrix M. There is another thing that is missing, is this square bracket. So I type this square bracket. Okay, so let's see. Okay, here there are our arrays, our scalar, and this is P that is composed as we wanted. Of course, you may need a bit of practice to understand how to compose matrices, but the important thing is that you are free to compose matrices in the way you want, the way you prefer, but you have to respect the geometry of these matrices. Okay, so this was the first point. Now I don't close MATLAB. Second part, operations on arrays. So when we perform arithmetic between an array and a scalar, we will perform this arithmetic, let's say, element-wise. So our operator will be applied to each cell of our matrix. For example, now I clear all the outputs. I clear the outputs in this way. We will see few examples on these kind of arithmetics. So first we define two generic matrices X and Y with the function randy. Again, we have a matrix of size 2 by 3 in the interval between 1 and 5. Here you find that the first argument is Imax, as MATLAB is suggesting us. So Imax is the largest integer in sample interval, positive integer. So it's the maximum value that we will find in our matrix. If you click on an argument of a function, MATLAB will show you suggestions, and in this case we can recognize that 5 is not one size of the matrix, but is Imax, and we can see that the size 1 is 2 and the size 2 is 3. Okay, just to be sure it is clear. So again, we can, for example, create a matrix x2 which halves each value in x. We say that this is x, so if we type x divided by 2, each individual cell of x will be divided by 2, and this is done element-wise. So this operation is performed on each cell of our matrix. The same, of course, is true for subtractions. If I run this part of the code, we can see that here we have subtracted 3. We have subtracted x to the number 3. So we have done 3 minus 5, 3 minus 1, 3 minus 4, and so on for each cells. Okay, then another interesting thing, of course, is that we can subtract matrices. Here I show you again x and y, and I run this action. Again, this was x, this was y, and this is y minus x. Y minus x is 2 minus 5, 5 minus 1, and so on. So again, we have performed an operation element-wise. We have compared each cell to the corresponding cell in the other matrix. Another thing, just to conclude this part, is that we can, for example, compute the mean value of two matrices. So if we can sum our matrices and then we can divide the sum we have performed. In this case, we have two matrices, and so we divide by 2. If we have 3 matrices, we divide by 3, of course. Okay. Again, this is the mean value of the matrix x plus y. Okay, I think that this is simple, but we will see that is not always as simple. So here, another mention on functions. There are functions like the sign that can accept as input, as argument, a matrix, and again here the function will be applied to each element of our matrix. So if we type sign of A, where A is a matrix, we will obtain a matrix that is composed of the sign of each cell. Again, this is simple. We can test this thing on with another function, the round function. What it does. So we can type in the command window. Of course, we can type whatever you want, but in this case, we can ask MATLAB the documentation of a function. So if we type doc, that stands for documentation, I think so, it should be documentation, doc round, we open the documentation that is really good in MATLAB, and we can see what it does. It rounds each element of x to the nearest integer. Okay, then of course there are other arguments that are not useful in this case. So this is how we can access to the documentation of a function. If you have a doubt, you can always type doc and then the name of the function. Another interesting way of check a function is help. Okay, I wrote it here, but in the command window I was saying help. If you type help and you type round, for example, you see again a quick documentation, quicker way. This is a quicker way of accessing the documentation. Okay, again, we have seen how to check a function, what it does. So now let's run this code. Okay, we have rounded the matrix A. 3.5 became 4, and 3 remained 3, and so on. Okay, this is how we can use functions on matrices. Then we have said that it is possible to operate element-wise, but there are operations that don't work element-wise. This is the case of matrix multiplication, the traditional matrix multiplication. So there is the need of distinguish the element-wise multiplication from the traditional matrix multiplication. So with the asterisk in MATLAB, we are referring to the traditional, let's say, matrix multiplication. So we will multiply this row by this column, and so on. While for the element-wise multiplication, we will use the same operator, but with the dot before. So in this case, it is possible to distinguish traditional operations from the element-wise operations. And here we can find a few examples on this. If you want to multiply x by y in an element-wise way, we just put the dot before, and we perform the multiplication. Again, maybe it's better if I show you this. Okay, 5 by 2, 1 by 5, and so on. This is element-wise. Okay. The same thing is true for divisions, and if you want to raise each element to the power. Just for just because we mentioned it, we can try the traditional multiplication. So we can type x times y, but I think that the dimension will not match. In fact, MATLAB says that for this operator we are using incorrect dimensions. We have to check that the numbers of columns in the first matrix matches the number of rows. So I show you again the two matrices, x and y. So as MATLAB says, we have to check that the number of columns in the first matrix matches the number of rows in the second matrix. For this reason, we can do something like this. So now y is a 3 by 2 matrix if we use the transpose operator that we have seen before. So now I run the code, and this is the matrix multiplication. This is no more element-wise. Okay, this was just an example, but keep in mind that the message is that be sure that you are using the right operator. If you want to use an element-wise operator, you will always use a point, dot in front of your operator. If you are going to use matrix multiplication, divisions, and powers, you use the traditional sign. Okay, that's it for operators. I think I'm running out of time, so I will be a bit faster. Accessing arrays and matrices in general. Okay, once we have created our array, maybe we want to access to one value, and how can we access to that value? Of course, we can, in the case of a variable x that is an array, we can type x, and in the parentheses we put the index of that value. So we are just typing, we are just giving MATLAB the index of our value, the coordinate of our value. This is the way of accessing one value. but it can happen that we want to access to a range of values. So if we want to access from 3 to 5, we will use the column operator. So in this way, I think that the image speaks for itself. But there is also another interesting, I would say, operator, interesting way of accessing arrays, and it is the AND argument. If you type AND, the index will be the end of the array, no matter how long it is. So this is useful when you don't know how long is your array. Somehow your matrix, your array could vary in time, could vary its length in time, so you are not aware of the size, but with the AND, with the operator AND, you always know the last element. Another way of accessing arrays is using different indices. So we have seen the single value, the single index, the range of indices, but maybe we want to pick different values, and we just provide MATLAB, we just provide the indices of the values. So the first, that is 2, the fourth, that is -1, and the sixth, that is 5. And here you have a very good example. So let's see some examples of what we have seen. Well, here we create an array. I could clear all the output, clear all output. So again, when these are the variables that we have created before. I add one thing. If you want to clear our workspace, it is possible by doing it manually. So right click on the variable and we can delete it. So we delete Z. There is a warning, okay, and it's gone. So this is the manual process, but maybe you want to clear all this stuff, and so you can use a function, MATLAB function, that is clear all. When you type clear all, okay, you will see that your workspace will be cleaned. If you want to clear just one variable, you type clear and the name of the variable. That's now is the workspace is empty, so I can't clear a variable, but a equals 3. If I type clear a, okay, I created a. If I type clear a, you can see that a is gone. So you can decide if you want to delete just one variable or all the variables. Let's back to our example. So we define our vector x. Here I change our output. Okay, 1 by 12. Okay, access the first element. As you know, just the number of the index, x1. I run the code, very simple, 19. Here I have to say a very important thing that I forgot to say. Differently from C++ and Python and other languages, the indexing starts from 1. If you type if you use the index 1 in Python, the index 1 is not the very first one, but the second one. This is because in Python or C++ or C, the indexing starts from 0. This is a difference. It's nothing too important, but keep in mind that in MATLAB, the indexing starts from 1. So here, the first value has index 1. In C, you have index 0. Okay. So as we have seen before, we can access to different elements just by creating an array of indexes. So here we have our array of indexes 2 and 4. So it will access to the second and fourth elements, and then we type again x brackets idx. That was our variable. I run the section, and here we extract our two values, the second and the fourth. Okay, again, as we have seen before, with the operator, it's not an operator, just a, let's say it's an index. With the index and, we access to the end, but we can also use n minus 3 if we want to access arrays starting from the end. Okay, last task. Okay, we can extract a range. In this case, the range from 6 to the end. Okay, so the first 5 elements will be drop out, will be not extracted and assigned to X range. And that's it for this part. Now there is this second part, so I will, okay, again we define a column vector x. We can access an array and change its values. So if we type x, that is this column vector, from 1 to 3, so our first 3 elements, then it is possible to assign 2 to these first 3 elements. Let's see. Okay, and here we see that the first 3 elements are now 2. It's the same concept we have seen before, but now we are assigning values to our array. Now, again, the same way we can do this stuff, but I think that I don't have a lot of time to show you all the examples, so I will skip this part because I think that you got the message. Okay, here you have some exercises. And here starts the part on matrices. We've seen how to access arrays, columns and vectors, but the same thing is true for matrices. I have introduced matrices like chessboards, and in the same way you can extract values from arrays. So you just type the coordinates. You just type the coordinates of the value that you want to extract. The first value will be always the number of the row, and the second one will be the number of the column. So M2, 3 will be the second row of M and the third column of M. I think that it's very easy, and in the same way you can decide to access multiple values. So here you access the second row and the items 3 and 4, so the third and fourth columns of this matrix. Again, I think that it is intuitive, as very similar to what we have seen with the monodimensional arrays. Okay, you can also extract ranges, slices of a matrix. So here again you go to the second row and you take the columns from columns number 2 up to columns number 4. Then there is the possibility, and this is widely used in computer science, to extract just one column or just one row. In this last example, you extract the second row just by saying go to the second row and extract all the columns. So with this operator we will extract all the columns. The same if we invert the 2 with the columns, we will access all the rows on the second columns. Okay, so very simple, 2 exercises. Here I define my matrix M with the function run that we have seen before. Okay, so we want to extract these values. What we are going to type? Well, we are going to extract the row number 4, so the first argument will be 4, from column 2 to column 3. So we can type from 2 to 3 with a column operator that says we are defining a range from 2 to 3. Okay, second example, again we want to extract these 4 values, so we are going to extract rows from 3 to 4 and columns from 2 to 3. Now I think that this is wrong, so from 3 to 4 and from 3 to 4 it should be like this. Okay, 1, 2, 3, and columns, no, okay, it was right, from 2 to 3, sorry. Okay, again the same thing can be done with this slice, so we will extract all the rows in column number 2, and that's it for indexing. Okay, very last script that I want to show you. I will be fast as I can because I'm running out of time. I promised you 1 hour and a half of seminar, even if the original MATLAB fundamentals is 20 hours. So okay, we can talk about statistics. So there are statistics functions that extract meaningful values from our arrays and matrices. So we start by defining X, that is a column vector of 20 values. Then we can evaluate the maximum value of our array. Here we have M, that is 0.97. Okay, it's not shown here, but I promised. Okay, but it's somewhere here. Maybe you found it here. Okay, so it's telling the truth. The same thing can be done, but we can also extract the index of the value, not only the maximum value. So I will explain it better. If we type max x and we take both the two output of the max function, we will extract the maximum value and the index, so where the maximum value is located in our array. Same thing for the mean, but we can also sort our array. Okay, usually the statistics functions work column-wise, so from the top to the bottom. In this case, for the mean, you will get the mean of each column, but it can happen that you want to evaluate the mean on the row. So this part was just to show you that you can use the mean, the max, and the sum, that are other operations that you can use on matrices. But what I want to show you that is more interesting is that you can also decide to use an operator not column-wise but row-wise, so along the second dimension, let's say. How can we do it? I will show you. Okay, now I'm getting an error because this is text and this is cannot be run. So I can comment this part of my comment with the percentage sign, and in this way it will not be executed. But I can also, as we have seen before in the very first part of my talk, we can convert it into text. So as you can see now, it is part of my documentation and it will be not run. So finally I run this part of the code, randy, so random matrix of size 5x4 with maximum value 20, and let's see, we want to evaluate to create a column vector containing the average of our matrix, but the average of each row. If we type something like this, we get the mean value of each column. As you can see, we have 4 columns and we have 4 mean values, but if we specify the dimension of our operator, so typing 2, we are saying please don't go in along dimension 1, but use dimension 2. And in this way we are saying we are getting the average of each row. We have 5 rows, so it's good to know that we are getting 5 rows, 5 mean values. Okay, the same thing is true for the median function. Just run to show you that it works. And again, you can use the mean function to extract the minimum values. And I would say that that's it for my part. It has been long part, but I hope you got the most important messages. If you have questions, now I will switch to the chat of this event, so I will answer all your questions. And I leave the floor to Matilde, if Matilde is still here.
Here I am. Hi, Luca.
Okay.
Thanks for your introduction to MATLAB. It was really interesting. And so if you want, I can share my screen.
Of course. So now you should see the split screen. Okay, so are you ready, Matilde?
Yes.
Okay.
I share my screen. Okay. Can you see it?
Yes.
Okay.
Thank you.
So now we can start speaking about another topic, another important topic of MATLAB. So we can talk about plot and why is plot so important in MATLAB. First of all, we have to say that when we analyze data, we have to find the best way to visualize data. If we see in the first figure here in the Livescript, we see that we have lots of different curves because we want to compare different curves for international gasoline prices. So it's important to visualize the data in the right way. But if you want, you can also go and see another type of plot. You can also see only the plot for one country, so for Germany, for example. This brief introduction was only for you to understand why plot is so important. For this reason, we see that in MATLAB there are different types of plotting functions. Today we will see different plotting functions like plot, subplot, scatter, bar, stem, stairs, area, pie, and histogram. So maybe we can start from the first example to understand the importance of plotting. First of all, we want to create 3 data vectors for Australia, Germany, and Mexico. In these 3 data vectors, we want a vector that contains gasoline prices that are random values. So as Luca said, if you want to create a random vectors, you have to create with the function rand. But if you want to create it, you have to know the dimension. So first of all, you have to decide the period of time that you want to consider and that you want to analyze for your data. Now here we chose a specific number of elements that if you want you can change. Here is 30, so the number of elements is equal to 30. In this way you see that the first vector here will have values from 1990 to 19 plus NL that correspond to the number of elements. So from 1990s to 2020. So the dimension of here is really important because when you want to visualize, like in this figure, you want to see this trend of gasoline price for one country. You have to define the x value here that corresponds to the vector here, and the y values that here correspond to the gasoline price. So the gasoline price for Australia, Germany, and Mexico. When you want to plot, it is important to understand that the dimension of the x values vector and the y value vector must be the same. So if we have a 31, actually a 1 by 31 row vector, here Australia must be another vector, another row vector of a dimension equal to 31 elements. So first of all, we have created three vectors of random numbers multiplied by different constants, and now we can go and plot this data on our figure. First of all, if you want to create a figure, you have to write the command figure here. With this command, you will create a blank figure, and so secondly, your aim is to plot the curve. If you want to plot the curve, in this case, you have to write the command plot. The command plot is a function that wants at first inputs the vector of the x value. The vector of the x value corresponds to here, as we said before, because we want to analyze data and visualize data in a specific period of time, so from 1990 to 2020. And after a second input you have to consider one of the previous vectors, so or the Mexican one, or the German one, or the Australian one. The first plot will be for Australia. So first of all, we will have the y values corresponding to Australia. If you want to plot some data, you can also specify which color will be which color you want to select. So you can specify the letter R if you want to refer to the red color. When you plot a function, you want also to add some other properties of the figure. So, for example, you want to add the title. In this example, the title is Australian gasoline price. So you can use the command title, and you can write inside this function a string with the title that you want to have. For your figure. After, you can use the X label. The X label command is really useful if you want to have a label for the x-axis. So, for example, here we can see that the x-axis corresponds to year, so we have to give in input the string year. If we want instead, for the y-axis, the gasoline price, we have to write this string inside the function epsilon label. So we can proceed in the same way also for German and Mexican. So another time we can see the plot as in at first input the x values. The x values, while in the second input there are the y values, and you can select another time the color that you want to visualize. In this case, green corresponds to the letter green. So maybe we can go faster, and we can go on a Mexican gasoline price trend, and we can see that the commands are the same, so we have to create another figure. So we have the blank figure. After, we have to create our curve, and we create with the x values years, and the and the y values Mexico, and we want to have this curve in black. So in this case, black corresponds to K. So now we can go on, and because we have seen how a figure can be created. But now we want to gather the previous figures, and it is possible thanks to the function subplot. If you use the function subplot, you will obtain this result. So what is, we have to explain this result. This is only one figure where we can locate different graphs in different positions. So for example, first of all, you have to create your figure. The figure corresponds to all the figure that we are seeing now. After, we have to locate the different graphs for Australia, Germany, and Mexico in the different position. So first of all, we have to divide the figure in different rows and different columns. So if we want to see the result that we will obtain, we see that in this case we have only one figure, and we have two columns and two rows. In fact, we have to set the number of columns and the number of rows here in the first part of the code. After, as I said, you have to create our figure, and with the command subplot, you can divide the figure. Divide the figure in n rows and n columns. The third inputs correspond to the position of the graph that we want to visualize. So, for example, Australian gasoline price trend will correspond to the first position. In fact, the third input is equal to 1. Now we have selected only the position of the graph, but we want also to plot this graph. To plot this graph, we will have to use another time the command plot. As we said before, command plot as an input, as first input, the x values, in this case here, and as second input, the y values, in this case Australia. And another specific, and we have to specify another property of the line that we want to visualize. In fact, we want to visualize a solid line. To visualize solid line, we have to put here, to write only one dash. We will see that there are lots of different types of line. For example, if we go on and we analyze the German gasoline price, we see that we have to define another time subplot. It's because another time we have to define the position that will assume the German gasoline price. Secondly, we have to write plot to visualize the German gasoline price, and this time the color will be green because of the G here specified, and we will have also a dashed line. This because here I specified not only one dash but two dashes. Now we can go on and we can see also the Mexican gasoline price. So we want to add also this graph to the figure. To add this graph, we have another time writing subplot so that we can specify the location of the third graph. In this case, the position will be 3. Another type of line of the plot will be the dotted one. So if we write the column, we will obtain a dotted line, as we can see in the Mexican gasoline price. A black line, but it is dotted. Now I think that we can go on, and we can visualize the three different trends for each country, but now we want to visualize and compare them. So if we want to do this operation, I think that the best way to do it and obtain this result is using plot and hold on. As we said before, we have to create our blank figure with this command, and after we have to draw our curve. So we will use another time plot, but in this case we want also to plot also the German gasoline price trend and the Mexican gasoline price trend. To obtain this result, we don't have to create other figures, so we will have only one command for figure, but we will add the command hold on. This because hold on allows us to add figures, to add graphs, to the same figure. The result that we obtain is this one. So we have different curves in the same figures, and we want to add also a legend in order to understand which curves correspond to the specific country. In order to add the legend, you have to specify, you have to write the command legend, and as first input you have to put the string for the first country. As second input, you have to put the string for the second country, and so on. If you want to specify the location of the legend, you can write also location, and you can specify where you want to locate your legend. For example, in this case, we want to position the legend outside the figure, but in the northeast position. In fact, we wrote northeast outside. It is important to say that when we use plot and hold on, we have to also use hold off. The command hold off is really important because when you want to add plots in the same figure with the hold on command, after you have to write this command hold off in order to say to MATLAB that you don't want to add other curves. So another thing that we have to say is that in this case we wanted to analyze the data in a specific period of time, so from 1990 to 2000. So to reach this, to achieve this result, we had to consider only the first 11 elements for each vectors. So in this case, as Luca said, if you want to use the right index, you have to specify the elements from 1 to 11, and the same thing we have to do for Australia and the other country. This because, as we said before, the x value vector and the y valued vector have to have the same length. So I think that we can go on. Maybe I can, okay, we have time, and we can see the scatter plot. So why we have to use another function for plotting? In this example, we see that scatter is a function that allows us to visualize data, to visualize scattered data. So, for example, we wanted to visualize cosine values with random noise. First of all, we have to define, as before, the x value vector and the y value vectors. First of all, if we wanted to create this vector, we will have we want values from 0 to pi multiplied by 2, where pi is a constant already defined in MATLAB. After, we wanted to define the step. The step, I think, as you can see, we can choose the step if you want. In this case, I chose 0.1. But now we can also create the y vector, the y value vector. So we said that we need the cosine values with random noise. So we define the cosine values with the cos function, and the cos function will have as input the x values that we have already defined. After, we have to sum another vector that has the same length of the cos x cut. And we will have, so to create this vector, we have to use the command rand. That will be a row vector of a dimension equal to the dimension of x cat, as you can see here, because with the function length you can find the real length of this vector. Now we want to define also the size of the marker. The marker, you can see the marker here in the figure, and you can change the value that you want. If you change, you see that the plot will change. So I decided to put 60, and now we are able to define the function scatter, because we wanted to write scatter, and we will have, as like in plot function, we have the x values as the first input. As the second input, we want the y values, and has third input, we want not the color this time, but we want the marker size. After, we can specify the color, so as for input. As I said before, if you want to change the marker size, you can see that if I change the marker size, we will have marker that are bigger, for example. Okay, now we can see that another command for plotting is also axis equal. Axis equal is a command that allows me to have the same length for data units. Now we can go on, and we can talk about stair-step graph. So what is a stair-step graph, and why we have to obtain it? First of all, we want to compare this type of plot with the plot function. If we define the x values here in the x vector, and the y values in the y vector, we will obtain these two vectors that we want to visualize. In the first time with plot, in the second time with stairs. Okay, now we can see that if we compare these two curves, we will obtain a different result with the function stairs that has as first input the x values and as second input the epsilon values. We will obtain a stair-step graph. As you can see here in the figure, the red line. While with the plot function, we can obtain this type of this line, this blue line. So now we can see the difference between plotting the same data with plot function or with stairs function. Another properties that we can add is the command x6 and the command x6 labels. So first of all, we can analyze the command x6. X6 help us to define the position of the tick mark. As we can see, we want tick mark in the position from 0 to pi multiplied by 2. With a step of pi divided by 2. So in 0, in pi divided by 2, pi, and so on. After this, we can speak about the tick labels. So we want to define also not only the position of the tick mark, but we want to define also the label of this tick mark. So, for example, if we want not to have the number of pi divided by 2, but we have to have the symbol of pi divided by 2, like here in the graph. We have to specify it with the x tick labels. And when we write pi divided by 2, we have to add this backslash. This backslash permits to obtain the symbol that we see here in the figure. Another command of the plot that is really important and it is really elegant is box off, because I don't know if you remember the first plot. Here there were two lines, two black lines. And this was the box outline. So if you want to remove this plot, this box outline, you can use the box off, and now you can see that these two lines are removed. Okay. Okay, I think that we are running out of time, so I will be really fast in the final graphs. So we want another. We can analyze another type of plotting function, the stem function, and in this case, the stem function is used when you want to plot a discrete sequence of data. For example, in our case, is a sinusoidal data because we are using the same data as before. And here we can see that the visualization is different from a plot because we can see the discrete data. So stem plot is important if you want to plot discrete data. Another type of plotting is can be reached with the area plotting with the area function. Thanks to the area function, you can plot data, but at the same time you can fill the area beneath the curve. So as you can see, we have the same x values and the same y values as before, but we obtain a different graphs. So we have, as you can see, all the area beneath the curve that is filled. Another important properties of plotting is the limit to if you wanted to set the limit of the x-axis x-axis and the y-axis. For example, in here we want to set the minimum at 0 and the maximum limit at pi multiplied by 2. As we can see, in fact, here on the x-axis you have the minimum value at 0 and the maximum value at pi multiplied by 2. After, we can also set the limits for the y-axis at -1 and at 1. So now you can see that there are lots of properties of the function, lots of different functions that you can use to obtain different visualization. And obviously it depends on the type of data that you want to plot. So to conclude, we can see different type of plotting if we want, for example, to make a survey. If we have a survey on sports practice at school, for example, we have first of all to create a vector, and in this vector we have the different percentage of students that practice a specific sport. So to continue, we have to define another type of vectors. In this case, we have a different type of vectors. In fact, if you can see, we are using another types of brackets. In this case, we use the curly brackets because we are creating another types of vectors. This type of vector is the cell array. The cell array permits me to have different strings together. So for example, we have specified different types of sports, but we can see that the first sport correspond to the first percentage and the second sport correspond to the second percentage. So and so on. So for it's the same also for basketball and football. Now we want to create the plotting with the pi function. So we have to give as input only the percentage. And if we give the percentage, we will have this result. So we can see the same percentage that we have set here in the graph, and we can also specify in the legend the types of sport that we have chosen before. You can see the same result also with the function histogram. The function histogram is really important because you can specify the categories. So you have to specify this string that has to be followed by the categories that we have chosen before. So in our case, this cell array. After, we have to define the bin count that in our case the bin count corresponds to the height of the bar, so to the y values of the y-axis. So now we can go on. We can also specify the color inside the bar if you want. In this case, we specify the color yellow, and we can specify also the color out outside the bar. And in this case, we specify the color red. The last plotting is about bar, is another type of plotting, like histogram. They are really similar, but in this case we see that the function is a little bit different from a histogram function. In fact, if we want to analyze another type of exercise, we see that we want to plot the student's age. So we define a x value vector. So in this case, this x value vector refers to the student's age, so from 12 to 18, and the number of students corresponded to the y value vector. In this case, this number corresponds to the number of students that have the same age. Now we can use the function bar, and we have the first input the x values, and the second input the y values, and after we can obtain this type of results. So we have on the x values the ages, and on the y values the number of students. So I think that I can finish here because we are running out of time, and I think that we can start again from next week, from indexing and logical operators. I hope that you liked our seminar, and I hope that we will see again next week.
Matilde,
yes,
are you there? We have a question in the chat from Theo that is asking if you can show us very quickly how to add the sliders.
Okay, yes. Okay. Okay, for example, here we have a slider. How can we put a slider? So I put the default layout so that you can see how the default layout is. With the default layout, now we can see that we have a different option. Here in the options, we have the options control in the section Live Editor. Okay, so in the section Live Editor, we want to select the option control. We click here, and we have different options. So what we are going to select is the numeric slider. So if, for example, put here a control, numeric slider, I will have a slider. When I have a slider, I can set different values. For example, for my previous value, for my previous slider, I had values from 0 to 0.1, but we can, for example, add different minimum and maximum. Here, for example, we can put 10, and here we can put 80, and we can choose also the step. We can choose a step of 1, for example. We'll have a slider that goes from 10 to 80, and the increase of the slider is of a step of 1. So, Theo, if you have any other questions, you can ask me.
I have another question instead. Do we find the same control in the Insert tab, right after the Live Editor tab? Just on the top, when there, you was there, Insert, up. Okay, on the left, is that the same? I would say yes. I'm not sure, I'm just...
We can try.
Okay, it's the same.
Yeah, I think so.
Because I answered in the chat, but my answer was different from yours. But these are two different ways of adding these control sliders. Just to be sure. Sorry.
Yes, so you can choose the option that you like more and that is more comfortable to you, I think.
Yeah, sure. It was just a curiosity.
So, Luca, if you want to add something, or if there are any other questions?
No, Giulio Birga is thanking you. So there are no other questions in the chat. If you want to ask something, this is the right time. If you are still alive in the chat, for those of you who are following us. Otherwise, I can change the scene. So for...
Maybe I can stop sharing my screen.
Yeah, sure. So, okay. Okay, so grazie Matilde, thank you very much. It was very interesting.
Thank you, Luca.
It was very interesting. We talked a lot. We have seen a lot of things. For sure, it was a bit tough, but we hope you enjoyed it, and thank you for being with us. Matilde, what do you want to say?
See you next week, I will say. So we can see you next week for the second part of the seminar, if you want, and join our group on Facebook and on Instagram.
Yes, because no one knows, but next week we will have a second round. We will continue this fundamental series, and we will conclude, hopefully, the fundamentals, the MATLAB fundamentals. The original course that you can take on the MATLAB site, but that normally would take about 20 hours, I would say. So here we offer you a much more quick version. And that's it. So see you next week. Thank you again, and
see you and bye.
And bye. Bye bye. Thank you.